It tests relational join mechanics, temporal data transformations, and candidate awareness of data shapes. Distinguishing a raw event log from a session-level record is a fundamental engineering competency. In analytics engineering, event logs are the source of truth. Take this activity table. Every session has two entries, a start event and an end event. The goal is to find the average session duration for each user. It sounds simple, but pairing events that live on separate rows is a primary source of silent query bugs. Let me show you the trap, why candidates fail, and how to write clean session queries. The most common candidate response under pressure is a simple group by user ed, averaging the timestamp column directly. If you write this, your query will run without any errors. But look at the output. You are mathematically averaging the raw Unix epochs of both start and end times together. The result is a meaningless point in time, not a duration. You've aggregated before pairing. Candidates suffer from a cognitive blind spot. They assume aggregate functions automatically understand the row boundaries of a session. But SQL does not know that one start row pairs with one end row. To bridge this knowledge gap, we need to restructure our query mindset. We must pair the events horizontally using a self-join before performing any statistical aggregation. Here is the optimal pairing pattern. We run a self-join on the activity table. We alias the first reference as nonus for start events and the second as nonus e for end events. We join them on both user ID and session ID, adding filters to isolate start and end types. Now that start and end timestamps sit side by side, we subtract start from end and compute the average duration grouped by user. In production, event strings can be noisy. What if a user opens the app but closes it without triggering an end event? If we use an inner join, these orphaned starts are dropped. If we must monitor them, switch to a left join. The missing end event returns null, which keeps the session visible while ensuring the AVG function naturally ignores the incomplete duration. Remember the pair first rule. When dealing with split row events, follow two phases. Phase 1. Pair events horizontally using a self-join on shared transaction IDs. Phase 2. Perform your arithmetic and run your final aggregation. Never run average or aggregate functions directly on raw event logs without matching row boundaries first. Let's analyze the AVG timestamp incorrect trap approach. Time complexity, O of n. Space complexity, O of n. Runs in linear time but produces mathematically incorrect results. Let's analyze the self-join plus AVG optimal intuitive approach. Time complexity, O of n, log n. Space complexity, O of n, requires index-back joining. Pairs rows based on user and session ID, allowing clear duration calculation. Let's analyze the conditional aggregation, optimal single-pass approach. Time complexity, O of n. Space complexity, O of n. Groups rows immediately and aggregates using case statements. Avoids costly self-joins, running in single-pass linear time. The interviewer will then ask, what if some sessions are missing an end event? An inner join naturally drops them. If we must keep track of them, use a left join and use coalesce or ignore null durations in the final AVG function. The interviewer will then ask, can you solve this without using a join statement? Yes, using conditional aggregation. Group by user underscore ID and session underscore ID, compute the difference between max case when activity underscore type equals end, then timestamp end, and min case when activity underscore type equals start, then timestamp end in a CTE, then average. The interviewer will then ask, what if timestamps are out of order or have duplicates? Deduplicate first in a CTE using window functions like row underscore number or compute min/max timestamps per session ID before joining.